Good morning, everyone, and thank you for joining us for another Webinar Wednesday. We're joined this morning by our Director of Digital Manufacturing, Lindsay Widmeyer, who will be taking us through the various digital manufacturing solutions we offer here at CAD MicroSolutions. Lindsay will be providing an overview of the functionalities included in Solidworks Cam, both standard and professional, as well as CAMWorks and SWOOD for woodworking. She'll be taking us through some of the newest features that Solidworks Cam has introduced for 2019, and she'll be giving us a demonstration of Solidworks Cam Standard, which, since 2018, has been included for free in all new licenses of Solidworks Mechanical. Please keep in mind that we will save some time at the end of the webinar for a question and answer period, so feel free to type in any questions you may have throughout the webinar. In the GoToWebinar panel on the right side of your screen, you'll see a section for questions. Just go ahead and type your questions in as we go. We'll do our best to get to them at the end, and if we do run out of time, we'll be sure to get back to you guys afterwards. So without further ado, I will pass things over to Lindsay to get us started.
Perfect. Thank you, Jessica. Okay, let me just quickly... I just have a really quick kind of PowerPoint here to cover before we get into the demonstration, and just kind of talking about digital manufacturing in general. So digital manufacturing at CAD MicroSolutions is composed of the Solidworks MBD product. So MBD allows the user to define, organize, and publish 3D annotations, including 3D modeled data in industry standard file formats. So this is essentially where we're taking into account the DIM expert options inside of SolidWorks, and we're using those in a way that we can create almost 3D drawings instead of the 2D drawings that we normally use. What we can actually do with this is we can organize them into different views that we would normally make inside of a 2D drawing. And they're completely readable just like a 2D drawing. And then we can also publish that into different readable formats that anyone can open. So 3D PDFs, that kind of thing. E-drawings, anything that anybody without even SolidWorks can open. So that's kind of a neat little package that we like to promote with the digital manufacturing. So Solidworks Inspection is the next product in here, and this is the ability to reduce the time needed to create inspection documentation, helping to eliminate input errors, improve quality, and reduce time to market. So this inspection format will actually allow us to either inside of SolidWorks create inspection documentation, so adding your kind of balloons and any kind of data to that inspection drawing. You can do that inside of SolidWorks. There is also a product for inspection that works as its own entity, so it's a standalone product. And this we can also open up any kind of CMM data and actually apply that data into our documentation that we create. So the SolidWorks Inspection product is a really good product as well, and also works with the MDD product. Then we're talking about the SolidWorks Cam and CamWorks packages. So these are the Cam products that I will be talking about in this presentation. And then we also have the SWOOD product, which is made for woodworkers. So any kind of router application would be a great application for the SWOOD product. So I'll just switch over into our CNC machining aspect and talk about the CAM product. So with SolidWorks Cam, like Jessica mentioned, we have SolidWorks Cam included in all of the SolidWorks packages. So SolidWorks Cam Standard is the included package, and that will allow you to program with 2.5-axis milling. We have 3-axis light machining tool pathing. We have tolerance-based machining. Automatic feature recognition, where we can find all the machinable features on that part. We have knowledge-based machining, which allows us to save machining strategies. You can actually teach the software how you like to machine different features. So let's say, for example, we're looking at a specific size pocket on a specific material. So if we're cutting maybe that pocket in steel versus aluminum, we're going to cut those differently maybe. So we might use a couple different roughing tool paths and a finishing tool path, whereas in aluminum, maybe we only use one roughing tool path. So we can actually teach the software how to strategize, I guess, those tool paths. We also have simulation inside that standard version. as well as a CAMWorks NC editor or SolidWorks Cam NC editor. And that allows us to take a look at the G code after it's been post-processed, and we can actually send that to the machine directly from the editor. We also have a universal post generator that comes free with any of our CAM softwares. That allows us to create a post processor directly for our machine. So we can create our own post processors with this tool. The SolidWorks Cam Professional package is the upgraded version of the SolidWorks Cam Standard, and that's where we get into 2.5-axis assembly machining. So if you're wanting to machine multiple parts on your 3-axis machine, you can easily create that with an assembly file. We also have 4 and 5-axis indexing, 2.5-axis volume mill, so that's our high-speed tool pathing technique. And then we also have turning included in that SolidWorks Cam Professional. So those are the SolidWorks Cam packages, and I will show the SolidWorks Cam Standard in a demonstration today. We also have the CAMWorks products. So SolidWorks Cam Professional is all included in the standard version. So essentially everything you get within SolidWorks Cam, so the previous versions here, all of this is included inside of the CAMWorks products as well. So you can kind of see that that whole package would be included in the standard. You would also get the ability to add in subspindle turning, as well as some rotary milling with that package. Where we get into the milling professional would be if you are actually looking to program a 3-axis machine. I highly recommend this package because you get all of the full, I guess, 3-axis milling group of tool paths. So that comes with undercutting capabilities and all of the different finishing techniques. So you can get some really good surface finishes with those tool paths. It also comes with a mill turn package. This allows us to program any kind of mill turn machine where you're looking at live tooling. The turning professional, so the turning professional would include also everything before this as well, but this also includes synchronous machining. So if you do have the mill turn machine with multiple turrets, you can easily program those with our synchronous machining. We also have a virtual machine standard simulation, as well as the mill turn package. So whether you're looking for milling professional or the turning professional, that's going to include everything prior to this as well. And then the last package here would be the full premium package, and that includes every single aspect of the CAMWorks product, as well as 4 and 5-axis simultaneous machining. So with the SolidWorks Cam Standard, you do get, or sorry, SolidWorks Cam Professional, you do get the indexing 4 and 5-axis. However, if you are looking to machine simultaneously, so moving all of those axes at one time, that's where you would get into the premium. We also do have a nesting product called NestingWorks inside of the CAM software. Inside of the CAMWorks package. So this is a standalone product inside of SolidWorks. So it is inside of SolidWorks, but it does not need to have a CAM software associated with it. So what we can do in here is we have the ability to specify grain direction, part and part nesting, again, full associativity with the SolidWorks software. So it does create an actual assembly file inside of SolidWorks. So anything we want to do with that SolidWorks part file, if we make any design changes, it's going to automatically update in that nested assembly. And we can obviously locate or create any kind of CAM program on top of the nesting software. So once we've got it nested, then we can create that CAM software. We can also export into DXF files or DWG files if we need to create that for a specific machine. And then when we get into kind of woodworking, we are also talking about that SWOOD product. So SWOOD comes in both SWOOD Design and SWOOD Cam. The SWOOD Design is essentially kind of a box design program, so where you can basically drag and drop different objects. So say, for example, you create a frame for a cabinet, and you want to drag in a certain amount of shelves or add a door to that, or any of the connectors that you might use to create an actual cabinet. That kind of thing would be inside of this SWOOD design package. So you can create as many different parts as you want, and you're basically just allowing yourself to drag and drop those pieces into your design. And then from there, we can actually take that design or any design inside of SolidWorks, and we can program that in the CAM software. So the SWOOD CAM has the ability to program with aggregates. We can add chip suction, multiple spindles, saw blades. There's a full nesting product inside of SWOOD CAM as well. And we also have post-processors for all of the well-known routers. So that is sometimes hard to find in most CAM software, so SWOOD CAM kind of covers that aspect of it. There is full reporting as well within SWOOD, both the design and in the CAM software. So we can create cut lists, tools list, the connectors, that kind of thing. So before I get into what's new with SolidWorks Cam, I'm just going to quickly show you the demonstration of SolidWorks Cam. So again, like I said, this is an add-in inside of SolidWorks, so we can just come in and turn our add-ins on. And then it's going to bring in a new tab inside your command manager, which is called SolidWorks Cam. The CAMWorks product would be identical, except for the fact it would say CAMWorks here instead of SolidWorks Cam. So that's kind of where we get up into the 3, 4, and 5-axis machining. This would be the CAMWorks product. It also brings in the SolidWorks Cam feature tree, the operation tree, and the tools tree. So inside the feature tree, we're going to be listing all of the machinable features. And then in the operations tree beside that, we're going to be listing the tool paths that are associated with those features. And the tools tree also lists your tool cribs. So we can create our own tool cribs. We can adjust the tools. We can make our own tools, whatever you need to do with those. So the first thing we might want to do is select the machine that we want to program this on. So we've got the option to define the machine. We select our machine, whichever machine we want to use. We would select the tool crib. We can also link a specific tool crib to that machine so that we don't have to select it in the future. And each of the tools you can kind of see are listed in the tool crib here. So we can add different tools. We can edit those tools, remove them right from within this window. And then we would also select our post processor from the machine window. So once we've got the machine selected, then we would go ahead and define our stock material. So I would go into my stock manager, and we would decide which size of stock we want to use to cut this part. So we can select the material as well in here, and this can be linked to, again, those strategies, the machining strategies, so that we can say, if it's steel, we want to use this strategy. If it's wood, we want to use this strategy. So you can create multiple different materials within this list. I think they've got over 1,200 different materials to choose from, and you can also create your own. There are 4 different ways to create your stock in here as well. So we've got the bounding box option. We can just basically add material to the sides if we need. We have the extruded sketch option, which allows us to use any kind of sketch that was located inside or created inside of SolidWorks. And then just basically give it a thickness. We have the option to use an STL file. We also have the option to use a SolidWorks part file. And the SolidWorks part file, we can actually use different configurations of the current parts as well. So that kind of, again, saves you from having multiple files that you're working with. We can actually create everything in the same file because, again, remember, all of the CAM data will be saved in this SolidWorks file. So we're just going to use, in this case, the bounding box for this part, and then I'll choose the OK button. Once we've got the stock set up, then I would want my coordinate system. So where do I want to place that coordinate system? So we've got a couple different methods. We can use a SolidWorks coordinate system. So I can create one from within SolidWorks and select that. Or I can use the user-defined method. So I can select any entity on the screen. If I want it in the center of the circle, I can place it there. If I want it on a vertex, I can place it there. So you can kind of click around on the screen and place it wherever you need it to be. We also have the option of using a part bounding box vertex or a stock bounding box vertex. So if I know that I want it in this bottom left-hand corner, I can easily just select a vertex there, and it's going to place it there for me. we'll choose OK here on our coordinate system. So once I've got the coordinate system set, then I'm ready to start programming this part. So we do have the automatic feature recognition, which is called extract machinable features here. Now, one thing before we select that button that I want to show you is under our SolidWorks Cam options, we do have the ability to choose which type of features we actually want to apply to this part, or that we want to find with our automatic feature recognition. So if I only want to find the holes, I can just check off the holes, and that's all it's going to find. So this is really helpful if you don't really need to. So we don't need to face this part because I didn't add material to the top of this. So I actually don't need to find that. It's going to save me some time in generating this. So if I choose extract machinable features at this point, it's going to go through the part and find the machinable features on this part. So we can see I've got my mill part set up one that it's created. So it's telling me that my tools are coming in this direction to cut this surface. If I had any kind of features on the opposite side that needed to be cut, it would create a separate setup for those, or if there was one from the side, that kind of thing. So it creates multiple setups depending on how many you actually need. You'll see that it created an open pocket on the top to create this tool path around this feature in the center. We've got some pockets here, some irregular pockets. Some slot features, and you'll notice the slot features have dotted lines where there's an open air edge, and that allows the tool to go past that edge if it needs to. The hole in the center, and then it's also created a whole group of any of the holes that would be the same dimension in diameter as well as the same depth for the depth cut. So we've got all of the different features that it's found here. And beside each of the features in brackets is what we call that machining strategy. So you can see for this open pocket, it's going to do a rough and a finish strategy. For the irregular pocket here, it's going to do a rough and then a rough rest and then finish strategy. So any of the strategies can be changed. So if we open up our parameters for that feature, you can see the strategy list here. So if I just want to do a roughing toolpath, maybe I just want the coarse strategy. If I just want a finishing toolpath, I can choose the finish strategy. So there's a whole bunch of different options in here. And what this one's been set to is to give me a roughing toolpath, then a roughing toolpath that just machines what's left over with a smaller tool, and then a finishing toolpath. So rest machining is basically the leftover machining. So that's applied to all of the pockets and the slot features. So if we go ahead and generate the operation plan, which is the next button in here, it's going to apply the machining strategy back to the feature. So you can see we switched over into our operation tree, and we've got all of our tool paths in here now. We come back into the feature tree. These have been generated, so they've turned black instead of the blue. And if we come back into the operation tree, these are now blue. So we can go ahead and generate the tool paths as well. And then if we hover over the tool paths in the list, you can actually see what they look like on the screen. So we've got a few tool paths that are still blue. These are actually the rest machining tool paths that weren't needed or weren't useful to cut the leftover material with that 1/4 inch tool. So we might need to obviously change the tool with those or maybe add them back at a later point. But you can see that they've actually, once I've deleted them, gone into a recycling bin. So with a recycling bin, I can at any time restore these and bring them back. So I just like to kind of keep them in there just in case I need them in the future. So now if we look at our program, you can see all the different tool paths that were used to cut this. Any of these tool paths can also be sorted. So we can, let's say, for example, if we wanted to put all the roughing tool paths together, we can just drag and drop them to wherever we want to put them. We also have the opportunity to sort the operations using the sort method in the software. So we can sort by either operation type or by tool. So I like to sort by tool, sort the tools by size. So I'll use my largest tools first. Maybe I want my center drills to come before my drills. And then I might want to sort by the operation type. So I want to do my facing, then my, then maybe my roughing after the facing, and then maybe the contour mills and so on. So you can kind of order these in whichever order you want. And you can also use or save these as different schemes so that you don't have to constantly do this. Once you press the apply button, you can see that everything's been sorted on the left-hand side here, and we're happy with that, so we can press OK. So that looks pretty good. We can also go ahead and simulate this once we've got the program. We choose the Simulate Toolpath button here. We are actually simulating against the stock material that we used in the beginning that we set up for programming. So we have two different methods to simulate: tool mode or turbo mode. The turbo mode will take us directly to the end of the program and show us just the results. So let's use tool mode, and I can slow the speed slider down a little bit so we can see what's happening here. So again, this is going in order of the program that I set up. So we can always double check that it's doing this in the correct order, and we can go back and change the order afterwards if it's not cutting in the correct order that we wanted. You can also see the depth cuts that are being made, and we can also adjust those if need be. So I'll just speed this up just to see the rest of the program here. So this is also a great opportunity to see what else needs to be cut. So you can see that our part perimeter still needs to be cut. And we've got these pockets here. If we use this, it'll show difference. It's actually going to show us in blue what still needs to be cut. And if there was any red on the part, that would mean that the tool is actually gouged into the part. We need to go back and fix that tool path. So you can see that there are some corners that still need to be cut in the pockets on the inside, but everything else looks pretty good other than that we need to add that part perimeter tool path. So we can fix those up as well. The first thing that I want to do though is I want to fix the contour tool paths that are cutting the pockets. So you can kind of hover over them and see exactly where they're located. So contour 2, 3, and 4. So if you can see, they're actually being used by tool 1. So if we come into our tool tree and we open up tool 1, you can see that those are the tool paths that are being used by tool 1. So what's happening here is I only have the 1/4-inch tool, flat end mill tool in my tool tree, and that was the smallest one available. So this corner that we have here, you can see that the radius is quite a bit smaller. So we can go ahead and add in a smaller tool in order to move those tool paths to. So if we right click on the tool crib, we can go ahead and add a tool from the tool library. I might want to add another flat end mill and make this obviously small enough so that it can fit into that corner. So we've got the 1/16 tool that should work. And it gets added to the bottom of the tool list. So at any time I can always edit that tool, make the station number different, that kind of thing. But I'm going to go ahead and take those contour tool paths and move them down into that tool. So if I highlight the 3 contour tool paths, I'm just going to basically drag them down onto that tool. And now I've changed the tool for those three tool paths. So I can come back into my operation tree, and we can see that those tool paths have changed. So we can always simulate, but I'll wait until I add the perimeter cut in first. So at any time, if we do forget to add a certain feature in, or if the automatic feature recognition doesn't find a specific feature, or maybe it finds it in the wrong setup, we can go ahead and add those tool paths in ourselves. So basically, we start with our feature. We need to right click on the setup that we want to add it to, and then we choose what type of feature we want to add in. So this is actually a part perimeter feature, so we'll select that. And then we get to choose what the feature type is. This is an open pocket type feature because I want to rough and finish around the outside of this profile. What is the strategy? How do I want to cut this? I'm going to do the rough finish. And then where do I want to cut this to? Do I want to go to the bottom of the part, the top of the part, the bottom of the stock? Again, bottom of part and bottom of stock are going to be the same in this situation, but we can even move this past the bottom of the part if we wanted to cut a little bit further. So I'll leave this as is. We'll choose OK. It creates our feature for us, and then we can go ahead and generate the operation plan for that feature. So there's my 2 tool paths. And you can actually see that these are being used by tool 20. So it's actually using the last tool that I just added into the tool crib. So I might want to change the tool before I even generate those. So I'm just going to highlight the 2 tool paths. And I might want to use the 1/2-inch flathead mill in order to program those. So now we'll come back into the operation tree, generate the tool paths again, and we can now see that we've got the rough mill and the contour mill for the part perimeter. So now let's go ahead and simulate, see our final product. So again, I'll just kind of slow this down so that we can see the actual tool paths. So there's our finishing tool paths that are getting into those corners now. And then we've got the part perimeter tool path. So again, depending on how we're actually holding this part on the machine, we can cut the part perimeter or not. We can maybe wait until we go and cut the second setup. So now that we've got the part created here, we can again double check with the show difference to make sure everything's green on the part. If not, again, we can go back and adjust some tool paths. Just to also give you a quick preview of what the actual tool paths look like. If we right click and choose edit definition on any of the tool paths, we can see inside the tool path operation parameters what we can change in here. Do I want to do a cleanup pass at the end? Do I want to machine any island tops if there are any islands in the center of this slot feature? What do I want to leave as an allowance on the side walls? Maybe I want to set this to 0, or maybe I want to leave an allowance so the finishing tool path can come in and cut that. Depth parameters. Again, you've got that rest machining, which is your leftover machining. So there's a whole bunch of different features that we can change. How do I want to enter this tool path? Do I just want to plunge in? Do I want to do an entry drill, a ramp, a spiral? We also have on the Optimize tab the estimated machining time. So this this software is also great for estimating or costing departments, just in case they want to quickly run an automatic feature recognition, generate the strategies as well as the tool paths. 3 buttons really kind of gets you an estimated machining time for that program as well. So we can get it for each tool path as well as for the whole program. Once we're finished and we're happy with that program, we can go ahead and post-process. So you'll see there's a post-process button at the top here. We can post the whole program or one tool path at a time or a section of tool paths. It's going to ask me where I want to save this. We can also choose the format that we want to save this as. Quite often the post-processor will tell us which format the machine actually needs, so it should already be selected, but we can save that. And then we've got the post-process window here. So again, I want to open this G-code file into my editor once it's been created. So I'll just create it first by playing through this. You can create it line by line, or we can just play through it, or just run through in fast mode. But once I press the OK button, it should open up directly into my editor. So this is the editor here. And basically, you can see we've got a whole bunch of different find and replace options. Do I want to search to the next tool change? You've got different NC functions that can be added in here. So adjusting the feed rates, adding in spaces, that kind of thing. And we do also have a backplot function. So this will actually allow us to preview what the actual G code is going to look like when it's on the actual machine. So just a quick little simulation inside the software. So if I speed this up a little bit, should be able to see the actual tool in here. And then as it runs, we can actually see it running along with the G code here. So just get that so we can actually see it moving. But again, we can change the tools in here as well to match the tools that are in our machine. But this, again, is just a really good check before we run this on the machine. And again, we also have the option to renumber and mark and delete different ranges of this code. So we can adjust and completely edit the code within this window. Perfect. So again, that's kind of just a quick overview, a quick demonstration of the software. So again, in our questions, in the question panel on the right-hand side, if you do have any questions about that, please let me know, and I can answer those at the end of the webinar. But I'm just going to go back into the PowerPoint that I have here, and we'll talk about what's new in SolidWorks Cam 2019. So the first option here is neck and tapered milling tool option. So you can kind of see when I opened up the tooling settings inside the tool path, there's now this non-cutting portion. So if you've got a tool that actually has a different shaped neck, or the non-cutting portion, so the shank, we can actually make that look like the actual tool. So you can kind of see in this preview here, there's a small little divot before the actual cutting portion. So again, we can kind of create exactly what the tools look like in the software now. Previously, it would just be a straight line all the way down, and it would seem as if it was going to gouge if it came anywhere near that shank portion. So that's a new option inside of 2019. Then we also have corner and arc feed rate settings. So this allows us to enable corner slowdown, arc feed rate, so you can see the arc feed rate overrides down here. So this is a really key aspect of programming and your feed rates for doing arc moves. Machine-specific technology database strategies. So this is a really great addition to the new software. Basically, what we can do is for different machines. So let's say, for example, you're programming both a milling machine and a laser machine. Those two machines are going to have totally different strategies that are associated with them. With a laser machine, you're really just using a contour tool path to cut all of those. So with these strategies, we can just set every strategy for that laser machine as a contour tool path. And that would be linked directly to the machine. So every time you select that machine, the default strategies show up with it. So that's a really great option. Tolerance-based machining is also added in now for turning. Previously, it was just for milling. Just in case you guys aren't familiar with what tolerance-based machining is, but that actually takes advantage of any of the dim expert tolerances, surface finishes, anything that you've added to the actual part file in the CAD model. We can actually leverage those tolerances and use different strategies based on the tolerances or your surface finishes. So SolidWorks came out with these Machinist Bundles. So hopefully you guys I didn't cut out too early in this section, but again, two different bundles for shops that maybe, for example, if your programmer doesn't really do a whole lot of design work inside of SolidWorks, these are two great packages for that person because it's not a full version of SolidWorks. So say, for example, with the Machinist Standard, what you're getting is the ability to do parts only and milling only. So it's basically the SolidWorks part only modeling environment that allows you to, you can still use, you can still completely model parts and add champers and do all of that within SolidWorks. But what it is, it's just kind of a reduced version of SolidWorks with the SolidWorks Cam Standard inside of it. Same with the SolidWorks Machinist Professional. So this is now parts and assemblies. So both of these versions don't have the ability to create 2D drawings in them, but both parts and assemblies inside there. And then you also have the SolidWorks Cam Professional package. So again, these are a lot more affordable than purchasing a full seat of SolidWorks with the Cam package attached to that. What else do we have? So we have toolpath editing interface, so we can actually edit the toolpath line by line. These are the two editing windows that will pop open. So we can adjust the actual toolpath just by clicking on it within the edit toolpath window. So that's a big feature that we have available now in 2019. And we also have some volume mill enhancements. So again, volume mill is the high-speed toolpath that we've got included inside of SolidWorks Cam and CAMWorks. So this is purchased separately, but we do have the option of doing a bunch of different enhancements. So we can now do rest machining, different cut methods within the volume mill toolpath. So rest machining was a really big one for that. And again, we've got quite a few more features that I don't have pictures of, but again, if you have any questions on these new features, you're more than welcome to contact me or ask me about them. But again, improved user control over hole end conditions. Machine to mean tolerance, again, that's in the tolerance-based machining. generate toolpaths directly from the PMI, chamfer curve features, cutter compensation for curve features. So again, they've kind of enhanced the ability to add different toolpaths to curve features. So that's about it. That's about all I have in my presentation. So again, if you guys have any questions at all, please let me know, and I can get back to you about those.
Perfect. Thank you, Lindsay. That was wonderful. So sorry about the brief technical issues there, everyone. We do have just a couple minutes left in case anybody had any questions they wanted to ask. And we do have a couple here that have already been typed in, so I'll just fire them off at you, Lindsay. So the first question we have is, if I have a 3-axis mill, which package would I need?
So if you're looking at the 3-axis milling, so this is probably the most popular tool, or sorry, CNC machine that most people have. So that's a common question. And what you would be looking at with the 3-axis milling is the milling professional package inside of CAMWorks. You do have 3 tool paths inside of the Solidworks Cam Standard package, but those are 3-axis light machining tool paths. So basically what that allows you to do is cut down in steps on surfaces. But you wouldn't actually be able to cut back up the wall. So it is limited 3-axis machining. It is there, but again, if you do have a full 3-axis machine, I would highly recommend just upgrading to the CAMWorks Milling Professional package.
Great. The next question that someone's asked here is, do my part files have to be native SolidWorks part files, or can I program imported 3D models?
That's a great question. No, they do not at all need to be SolidWorks native models. So anything that you can open inside of SolidWorks, IGES, step file, anything like that, we can program inside of SolidWorks Cam and CAMWorks. So just basically needs to be a 3D model. We can program sketches as well, or DWG files, but to use the automatic feature recognition, it just needs to be a solid model.
Great. And one more question for you here. I believe this one was asked while you were demonstrating the SolidWorks Cam Standard, but the question was, can we delete any unwanted toolpath by just selecting it?
Yes, absolutely. Yeah, any kind of toolpath that you don't want. So again, that's kind of with automatic feature recognition and using those strategies, it looks maybe like you have to use those at all times. But you can always delete any of the toolpaths that it creates. You can add any extra toolpaths. So say, for example, you're using a rough finish strategy, we could add another finishing toolpath on top of that. So yeah, anything can be kind of manipulated and changed the way you want for those.
Great. So I think that's all the questions that we've got time for today, but if anybody does have any questions that they'd like to ask or they think of afterwards, feel free to reach out to us, respond to your email that you'll get from GoToWebinar, or reach out to your account manager, and we would be happy to get back to you on those questions. So thank you everyone for joining us today, and thanks again to Lindsay for a fabulous presentation, and enjoy the rest of your day.